Well, hi, good morning. Thank you so much for joining me in my shop. Today is February 9th, 2024. And just before I get going on the radio, the last video I posted, right at the very end, I tacked on one astronomy image that I took of the Orion Nebula. I took that just a few nights ago. So if you managed to watch the video right to the end, then this picture would have popped up. I did that with my telescope, the Dwarf 2 telescope. I'm not trying to promote it. I have no association with the makers of that telescope or anything. I'm just a guy who bought one, and I'm having a ton of fun with it. So I thought I'd put that image up there. Now that image is about as bad as it can get in terms of processing. I didn't do anything to it. That's right out of the camera. You can actually watch that image build up over time while the camera's operating, because that image is based on about 120 photographs that are stacked one on top of the other. Lots of fun. So that's why I put that there, because I've mentioned a number of times I'm having fun with this camera, and I suspect you and maybe other viewers too who are doing this kind of stuff are probably interested in astronomy too. You're probably very similar to me in lots of respects. So that's why I put that on there. And I think and I took that image, I say just a few days ago, on a clear sky night. Would you believe that's the only clear sky night that's happened in months and months here? Months and months and months. Holy smokes. Okay, enough on astronomy. Yeah, not quite enough on astronomy. I do all this astronomy stuff just for fun. There's no other reason. I'm not trying to do anything more than entertain myself. And what I found with the standard telescope, reflecting telescope or whatever it is, I've had a few of them, cheap ones, massive frustration followed by very little payoff. That's been my experience. Frustration aiming at all that kind of stuff. With this other telescope, the Dwarf 2 telescope, all the fussiness is eliminated. And I could be sitting with my wife on the couch and say, you know what, the sky's clear. I think I'm going to take some photographs with my telescope. And 5 minutes later, I am stacking photographs from the sky. So 5 minutes. 5. Count them. 5. Okay, enough of that. You can tell I'm pretty excited about it. Now, let's get on with this. So, yesterday I replaced a number of capacitors. I'm trying to stick in the audio circuits, but, I'm not married to it as such. This big one here got replaced, which is good. And what's coming next? So I can see a capacitor here and a capacitor here, and there's one up here. Looks like it's coming to the volume control. This one, what's going on there? Already I've seen something curious here. Curious, eh? It may not be. Just looks kind of odd. So what I just started doing was tracing the center terminal of the volume control over to see where it's going. And it passes by this terminal, appears to be in contact on its way to this capacitor. Now I've already placed one of these big square fat guys here. Maybe we should get rid of this one too. Now what's it doing? Is it attaching to the terminal there? Can you see that? Yeah, you can see it. The wire comes across. Looks like it's laying on the terminal. So there's nothing attached to the terminal. It's not grounded or anything. I think they're actually using it. I think this wire is actually coming here and then carrying on to go to here, because you couldn't run the capacitor lead all this distance. That's too far. They aren't that long. So that's what they've done here. They've utilized the terminal position here. Now it's kind of melted into the capacitor a little bit. Ooh, what does that sound? That didn't sound very good. But I don't think there's any problem here. Okay, so I'm going to include this capacitor because I did one like it, as I mentioned, and the result was surprisingly bad. So doesn't look like your average mica capacitor. This is one I know I broke this one open. I broke the other one. That's why I can't find it here. I smashed it open, and inside it was just nothing more than really a paper wax capacitor, if you like, arrangement. Whereas the mica ones are definitely different. Like one like this. This doesn't have wax and paper in it. And everything I say, you take with a grain of salt, because I could be wrong about it. So this guy you know what he's doing? He's imitating a mica capacitor. He's hiding the fact that he's a paper capacitor. So I add this one in the list. So let's see if today I can get through all the ones that are down here. That, and that. And anything else that happens along the way, because usually something happens along the way. Well, what should we start with? This one's a little weird. What's this one doing? It's coming from the volume control. So one side of the volume control is grounded, or sort of grounded. The other side is going to be... That's right. Now we're looking at the schematic, and the engineer had come up with all kinds of weird tonal control stuff. To me, it's weird. I'm sure it's not really weird. Well, we can look at the volume control. We can see what this capacitor is doing. It's all by itself going somewhere. What? Yeah, all by itself, but it's going somewhere. Okay, volume control is right here. One end is showing going straight to ground. I didn't see that. We'll have to look at that more closely. And the other end is heading off. And this is yeah, capacitor and a capacitor. Maybe it's this 0.02 one. It goes over to the switch. So this is almost certainly the capacitor I was just wondering about. So we have the output from the radio coming along, and then this switch is see, these are all wired together here. So until the switch makes it all the way over to here, the switch is just disconnected, just connected. I say that very clearly. And then the audio signal, going the wrong way. Audio signal then passes through this capacitor and then reaches the top of the volume control. And this capacitor's job, I'm pretty sure, is just to block any DC voltage that's developed in the detector here from getting any further into the radio circuit, the audio circuits, and allow the audio to pass. And I guess perhaps it can even block any RF that might be coming through. No, how can it do that? It can't. There shouldn't be any, though. It should be filtered out by this filter. Now this is pretty interesting. The last radio I worked on had it was another Philco radio, and had exactly this circuit right here. And also it was inside the IF can, same as this one. So this wire on this last radio I did came out and was disconnected. It was just laying unconnected, kind of tucked up under some other parts, so it looked like it was an oversight or a mistake on by a previous person. I connected this up, and when I did, the only result you could notice was a drop in volume. I think I did some experimenting to see about filtering the RF. Wasn't very impressive, if I remember right. Now this radio, I mean, it could be in that other radio, could be trouble with these capacitors. I don't know, because it was inside the can, and I wasn't about to go there. Okay. So, interesting stuff. One of the things that happens when you're working on these radios is every time you look at the schematic, you see a little more, because you can't absorb everything all at once. It takes time to drink in all the information. So you're looking at one thing. If you see something in the corner of your eye, it might be worth looking at. Like, what is this? Small white? Is that what that says? Small white? Well, maybe a small white wire. Maybe is what it's saying. I don't know. There were different thicknesses of wire coming out of the IF can, if I remember right. Curiously, too. I think they'd say thin white, not small white. Okay. Anyway, see, there's a perfect example of me being distracted, because I'm seeing stuff like this. Small White? Is that what that says? White? This just says white. I don't know. Maybe we look at the radio if I remember. I'll pay attention to that. Okay, so we're getting back to the capacitor that I identified. It's this one coming off the volume control. The other end is supposed to be grounded, eh? Oh yeah, that could be. Sure, it could be. Okay. Why am I saying that? I'm not going to explain myself. So, this one is a picofarad capacitor, and this one is not. This is probably one of the other ones I'm looking at. Or I already did this one. Coming from the combination of... Yes, they've tucked all these resistors right in between the volume control and the tone control. Okay, this one's got to go because, for obvious reasons, its brother wasn't very healthy. He won't be either. And it's conveying all the audio through the radio and trying to block a little DC. All these things are important. Yeah. Okay. Let's go. Come on, Jim. Let's go. Okay. First one I'm going to go after is just kind of like the most obvious one. This guy here. This is the one that's carrying the audio signal from the volume control over to the trio here where I'm clipping the clip. I don't think I can forget where this came from, but I surprise myself quite regularly with my talents at forgetting things and the like. Very greasy. The last one, the case was cracked. I don't think this case is cracked here. But it's a pretty dirty guy. Okay, let's give him the test. Let's put him to the test. And while that's warming up, we're going to give him a shot with this. I'm going to give him a shot. With the case not cracked, perhaps this is working better than its brother was. What do you say? I say you can't see it. Hard to see there. So this says it's a 12 nanofarad. That would be a 0.01. 12 nanofarad, yeah, 0.01. But it's supposed to be a 0.006, isn't it? Or something like that. So again, when the capacitor reads high on these tests, I think we can be. It sort of indicates to me that the capacitor is leaky and it's throwing the test result off. Okay, so watching the eye here, putting 50 volts on it. Wow, it's not even opening at all. So she's a bad actor. Now, if we look at the schematic again, which I think we should, I think it's important that this one be in good shape. Let's look at the schematic again. This is the capacitor I'm fooling with here, 0.003. And it's reading at 0.01. So, it's reading like 3 times its proper size on that device, which I said indicates it's probably leaking. Now, what would it leak? So, luckily, this capacitor is blocking DC from way up here, being developed up here, that DC from getting all the way onto the grid, unless this guy's leaky, and this guy's leaky too. So what if this wasn't here, or it's so leaky it's as if it isn't here? Then the whole AVC voltage, 5 volts, 10 volts, whatever it might be sitting here, it'd be divided down here. If this is leaking badly, you see it's a very high impedance circuit here. I didn't mention that. So we have 10 mega ohm resistor here. Might as well not even have it. So any charge that gets through here is going to build up. on top of this 10 meg resistor, and it's going to push the bias of this off. And what is the bias on here? So this must be self-biasing arrangement, I think. I could be wrong in this. I don't see any other bias method taking place here. So self-biasing with a leaky capacitor and DC coming in from another leaky capacitor. That's a bit of a long story, isn't it? Interesting that if you vary the position of the volume control, you could be varying the DC voltage that's leaked into here. Maybe varying the bias. I wonder what that would do. You have a big negative voltage here, and you turn the volume up. So you move this way, and all the minus 10 would be here, ready to leak through to here. You have it down here, most of the minus 10 would drop on this resistor, and you wouldn't have much. So turn up the volume, turn up the bias. That's what would start happening here. Those might be interesting tests to do on a radio before you cut the capacitor out, Jim. It's a little too late now, but could have looked for that effect. Okay, well, I'll put it on my list of things to do with the next radio, I guess. So, so change this guy, and I should change this guy next after that. Okay. Okay, so I replaced this capacitor and this one here, and I have this one here to test. And this would be the input to the volume control. So all the audio is passing through this guy, and according to my analysis, this capacitor and the other one in combination, if both leaking, could cause a bias problem on the triode. Maybe. And of course I was talking about the AVC voltage leaking through, and the AVC voltage is a varying thing. It depends on circumstances too. So lots of ifs. So what do we do here? 50 volts. What happens on the eye? She's open just a hair, so barely opening. So leaky also. Leaky enough? I wish I had done those tests. So maybe on the next radio I'll think of this, see the same kind of arrangement, and wonder, is the grid of the triode being pushed off by leaks of bias voltage or AVC voltage or whatever else might be happening through old worn out capacitors? That would be the interesting question. Who's next on the hit parade here? Let's take a look at this bigger one. Bigger job. I'm going to guess it really has nothing to do with the audio directly. I'm going to guess that this is the screen circuit silencer. Not sure though. How are we going to figure out where this one is? Because it's in between two. Well, first it looks like the only really big capacitor in here next to this one. So we could just find it by size, but it's between two terminal strips, which makes it really tricky. What is obvious here is one of them a grounded terminal. So this is a ground here. So it's a grounded big capacitor, and it's connected to this. Now what is this? What is this? A long yellow wire traveling up into the switch here, and a resistor, 2.2 megohms going this way to here, and then just going to another terminal. Come on, give me a break here. Somebody show me more resistors down that way. I think I'm gonna have to figure it out by size and figure out which one I think it is on the schematic. I'll look at the surrounding components, like this 2.2 megohm resistor, and see if I can find it. Of course, not this way. This way. It's a grounded capacitor with a big little resistor on one end. Okay, let's go looking for that. So I'm going to be suspicious that it's on the screen. So I'm going to pick a screen circuit here and just go along. Where'd my mouse go there? Crazy mouse. Just Going along. Ooh, look at this thing. That top line. That top line. Well, looky there. Oh, well, that's interesting. 10 microfarads with the positive. Oh boy, where's this capacitor? Okay, moving on. 0.02 is too small. Well, that didn't work out, but we found out that there's supposed to be a big electrolytic one on this circuit, on the screen circuit. And that's not surprising. Yeah, not surprising to find it on the schematic, but I didn't see this in the radio. Unless it's that one that I changed, because there was some confusion about the number of electrolytic capacitors in here. Okay, but that's not the one we're after. So okay, that didn't work. So if I just cast my goggles all over this schematic looking for a capacitor of that size, there's no parts list, is there? There is no parts list. Is there? No. No parts list. Okay, so I'm going to figure out what that capacitor is, and I'll do it after drinking a bit of coffee. That sounds like a great idea. Well, I found the guy. So here he is over here. 0.2. Let me just zoom out a bit just to get a little better perspective on where we are on the schematic. 0.2 is right here, right down here. And what you can see is one side is ground. Let me zoom back in. Come on, mouse, don't quit on me now. Right, so here it is, 0.2. And this is the only large capacitor I could find like this. And it's connected to a 2.2 megohm resistor, which I can see. The other one, I don't see the other one, so let's go looking for it. But I'll bet you it's there. Let's go. Okay. So the capacitor I'm talking about is this one. The grounded end is here. The other end is here on this terminal. And right there is a 2.2 megohm resistor connected to it, and a wire. You follow this wire all the way up here, and up here is the other 2.2. It's sitting right here. You probably can't see it, but it's right here. So that's what that guy is. 0.2. It's a pretty big capacitor. What exactly was it doing though? Oh, I don't really know. Let's go look again. So what are you doing here? Is it part of the? Oh, right. Huh. What? There's another 0.2 here. Wait a minute. Wait a minute. 0.2 to ground, and it's connected to a 1 meg here, 270 there, 470 up there. Yeah, this is a different one. I don't. Oh, I'll bet you this is the other what other style of capacitor. Molded. It's probably the molded capacitor. This is the molded one, because it is connected to a terminal with a whack of resistors coming off it in all directions. That's what this is. Okay, all solved up. So what is this capacitor doing up here? Oh, my mouse is quitting every 4 or 5 seconds. That's in case you're wondering why I seem to be mouse disabled. So phono tone compensation circuit for the model so-and-so, and this is the other tone compensation circuit. That's what this is. Well, look. Oh yeah, here's the cartridge, and look, it's coming right up into this schmozzle. So this guy's probably unimportant unless you've got it flipped over to phono. That's probably the situation here. It's probably not even connected. This probably feeds into the switch. Aha, feeds into the switch here. So only when this goes all the way around to here, you then connected this, whatever's happening is happening. Too much happening there. Okay, I could argue this isn't worth doing. No use changing this. I'm not about to play a record through here. Would that be true? Would that be true? I just forget this. Compensation. Besides, it's compensation for a 1930s record player too. So even if you want to use this input for something else, you'd have trouble here. Could this be having any bearing on the operation of the radio while not in phono mode? So I don't know what all this nonsense is down here. Holy smokes, and this is a high voltage here. 10, there's another 10 microfarad. Oh, it's okay. I think I'm mixing up a couple radios in my head here. Well, let's just go back and look. Let's follow this. So the cartridge signal comes in. Now, where's the switch? So the switch is way out on the end here. So the cartridge signal has been compensated for through this circuit, and now it's traveling on the W wire all the way out to here, where it's grounded. I didn't notice that. So it remains grounded all the way until you get to here. When you go to here, the ground comes off. Oh, the ground goes on here. The ground goes on here. That's what this is. This is deciding who's grounded. Phono grounded out, and this is almost certainly, going back to the output of the detector. So when you flip to phono, this switch grounds out the radio signal. So you can't hear it anymore. So so the whole time the radio's going, a ground is in place on this line. The whole time the radio's going, a ground is on place here. This capacitor is doing nothing for this radio. I'm not about to make utilize this in any way. So we're going to skip this. I'm just going to leave it in there. What about this other one though? Well, we managed to find this one. This one appears to be part of the power supply system. And I'm getting that because of this voltage here, but look at this one. Minus 4.8, minus 4.7 with an asterisk. What's the asterisk about? Probably says it must be in radio mode or something like that. Did anybody see a note? Where's the asterisk? Note. Ooh, down here maybe. Well, I don't know what they have the asterisk there for. Let's take a look again. There's all kinds of asterisks. There's a double asterisk here. Somewhere there's a note I've missed. And I totally lost track of where I am. Oh yeah, 0.2. Wish I knew what these were. A, B, D, C, D, E. These must be like test points, and they have some information somewhere about each test point, what you should expect. This one's pointing at a grounded spot. I don't get it. So, still not sure what this is doing. Oh, yeah, this is the main power supply filter right here. Oh, they mixed all this stuff together here. It comes down this way and up. That's the negative voltage. So I think they're playing the power supply trick where they don't ground the absolute bottom of the ground of the power supply. They make a voltage divider and apply the ground to the voltage divider. That's what this is probably happening here. And this leaves a negative voltage available. That's what probably this is. And this is really by the skin of my teeth. So here we have these negative voltages with a star, and they're going to be applied to grids. Yeah, applied right here. So it's very important that, now wait, now didn't I did the leaky capacitor thing, but I didn't really note what the negative voltage was here, but it was something like that, I think. If two voltages, one with a star, you take a wild look, it's only a 0.1 difference too, does this really matter to anybody? Probably it's between phono and stereo, or phono and radio, and this voltage changes ever so slightly, probably because of the change in the load on the power supply itself. And the change is probably meaningless, it just happens. So they've shown it here. That's my guess. So again, so what would happen if this capacitor is not here? Well, if this is a grid supply, if I'm right, and this is a grid supply, look, it's a big 1 meg resistor here, so it's all suggesting it's a grid supply. You want this to be nice, clean DC. Now it's not too hard to deal with because there isn't a lot of current. There's no current really flowing in this circuit here. It's going nowhere. It's like an open wire. So you don't need much. But there's a voltage divider happening here. Wow, this really blows my head away. Is this another? Oh, this is the compensation thing now. Whoa. How did this happen? How did I get from negative bias voltage to here? I thought this was phonotone compensation. Silence, yeah. No. Where's this go? So this must go to a grid. Oh, you know what may be happening? Let's just follow this again, because I've forgotten where it goes. It doesn't go to a grid. It goes to a grounding switch, and that's all. It goes to a grounding switch. Okay, so what I was imagining is not true. I won't even say it. So I still think this is just compensation for the, and what this is, I don't know. And that's going to be the end of it. So I can't be sure what would happen here, except I think if this were not here, you could get a power supply hum. Even with these filters here, they're not 100%. So if you're going to put a DC voltage right on the grid of a tube, you want to make sure it is clean DC. And that's what this is probably doing. So if this guy's not working well, hum. That's what I would conclude. Okay, that was quite a journey. This is the guy I'm talking about. He looks to be in great shape. But like, it looks very clean. Like, how did all this guy also greasy, ugly stuff? This guy's shiny clean. Replacement. It's possible it's a replacement. If the one end is just going to a grid, then it's open. I can put a test on here. This end is grounded, in fact. And this end is the one that's just going to these resistors, and then I don't know. Let's just do it. I'm thinking too much. Not getting anything out of it. Okay, nanofarads. So this is saying it's a 0.35. And my thinking is it's a 0.2. So if it's reading 0.35, then even though this test may be bogus because the capacitor's in the circuit, I think it's a good bet that it is leaky. So we're going to try and get this out of here. I think I can desolder this one here. Okay, just got to start up my soldering iron again. I think this has just been pushed through the hole here. I don't think it's bent. So there's quite a few components here. 1, 2, 3, 4 components all stuffed in there. I wonder if they got the wires twisted together before doing that. I don't know. We're pretty bound to replace this. So I'm going to cut it out. And then, because I know how stupid I can be, I'm going to put this clip lead here. Now we're going to test it again. So it's wrapped on the outside of this terminal, which again, it says replacement. Okay, let's test it again. The capacitor's shaking. He's nervous. Something's going on. So 0.25 nanofards, that's, or 250 nanofards, 0.25. So that's reading more than what it should be. Is it really? Is it really a point? Well, I don't know. Well, I don't know. Well, what's happened to it? Pyramid. You could pretend that that says 1 megafarad if you want it. But here's where the rating is. What happened? Who took the rating away? 400 volts, but what happened there? Or is that just dirt on it? I think that's just dirt on it. I think that's just dirt. Okay, I'll use my finger. Fingers are handy. We're lucky we've got them. It's going to say 0.25, which is just what I measured. Son of a gun. Let's put them in the leak, because now the indication is there's nothing wrong with this capacitor. Let's put them in the leak. I think I cut out a perfectly good capacitor here. Okay, 50. It's a 400 volt, so we can get up pretty high here. Starting with 50 volts. Opened right up. Looks perfect. 150. Oh, she's a good guy. 250. Look at this. This is like new. 350. This is the highest we're going to go. Wait a minute, what happened there? Okay, so when I let go of this control, it shorts out the capacitor and discharges it. So you see some funny things happening there. Well, there's nothing wrong with this capacitor, so what I'm going to do, I'll put this in my collection of capacitors. Someday it'll work its way back into a radio. In the meantime, I need a 0.25. Or is this not what I thought it was? And there's another capacitor in there. Maybe this isn't what I thought it was. No, you know what? This is a replacement. And the guy who replaced it stuck a 0.25 in where a 0.2 was. I got a story. I got a story and I can believe it. That's great. Makes humans feel good when they got a story they believe. Doesn't have to be true. So I have a number of NOS old stock capacitors that have never been installed, and some of these look pretty rough. I think they came out of a radio, but I don't think they did. And so I grabbed this one first, and it looks great. I put it to the test. No, this has got a leak in it already. Never been in a radio, it's got a little bit of a leak. I grabbed another one, this one here, and this one proved to be perfect. Perfect, just like new. So in it's gone. I think this is a 0.33. 0.33. That's right, yeah, this was a 0.25, so I've just gone up a little bigger yet. I don't think it's a problem for the radio at all. Bigger is actually better in those positions, probably, to a point. And, you know, law of diminishing returns, all that kind of stuff. And of course, the economics of building 1,000 of these radios. I'm trying to save a penny here and a penny there. Let's operate this radio now and see if it still works, because I've done a fair bit to it. And pretty sure I've done everything right, but that doesn't mean anything. Okay. I've done a fair bit to this. Speaker's still connected, antenna's hooked up, but I don't think it's switched on. There we go. Everything's good. I don't think the radio's switched on here. Yeah, there we go. You might have caught this meter in the corner of your eye, this one here. So this meter is showing the voltage at the output here. This meter, the one down here, is actually this gray cord here, right in the back of the extension cord. So it's showing the voltage right at the outlet here. But then subsequently I obtained this guy, which is a better way of doing it, 103 volts. But you'll see this meter jump around now and then. You might be wondering what's going on. There's no zero. The bottom of the scale is 100 volts. It starts at 100 volts. So until you get up to 100 volts, that meter doesn't move. And then after 100, it starts going up. Just in case you're wondering, and this is the line voltage in my house, approximately. Not quite exactly right, but close. Okay, that's what those are. Now, this has been on long enough to be making some sound. I had to turn it up a long ways to hear anything. Let's check the band switch position. Okay, so now we're in broadcast. So nothing on the antenna. So I am going to turn the antenna on. There's no reason why it should work any better than it did before when it comes to receiving signals, but I'd like to try. So I'm going to go turn the antenna on and we'll give the radio a chance to sing. Okay. Got an antenna now, the volume's much higher. Much more volume to it. We're on the broadcast band. Oh! You've got to be kidding me.
Continues to get worse because the original thing was there wouldn't have been an investigation at all.
Oh my gosh.
The Arrive Can debacle if the Liberals had had a majority government. They didn't, and this was one particular case where the NDP...
Well, that's, I don't know.
Ganged up except for the Green Party.
I'm a little bit freaked out here. So the radio is tuned somewhere in the upper third of the broadcast band based on the position of the capacitor. There's nothing up there to receive at this time of day. Oh, what's it doing here?
And then, as I said, the Auditor General...
Okay, so I'm going to tune the radio. I will not hold the tripod and touch the radio at the same time. So you just have to kind of watch the capacitor to figure out where it's tuned. Okay, so I know what this is. This is 860. Let's see. What happened that made this radio suddenly work? It's working great.
For the business report, Chris McCusker. Irene,
that's 680. 640. 590 coming.
When you open a banking package, a loan with TFSA or RRSP at Scotiabank. Rewarding.
Good volume, good sound, good tone.
You're richer than you think.
Richer than I think. Am I? I'm richer than I think. That may not be saying much. Well, I'm floored. I don't know what I did that would make it work at this point. Then why wouldn't it have been working before? Just to be clear, we picked up a shortwave station on the shortwave band, which convinced me the radio was operating, but I never picked up a station on the broadcast band till just now. Well, I shouldn't be complaining, should I? No, I should not be complaining. That's fantastic. That's a great surprise. Okay, that's the end of the video too. Fantastic. So off I go to enjoy my day, feeling a sense of success here, even though I don't know why. I shouldn't admit to that. I changed some parts and now it works. Pat me on the back. Okay, we'll see you later. We'll see you in the next video.